we're looking here at a velocity time graph of a sprinter running a race. Okay, and we're asked in the first question to simply describe the motion of the sprinter during the first 0.5 seconds of the race. Okay, make sure we read this one carefully, okay, because often this is misread as during the 5 seconds. We're not actually asking about the 5 seconds here, we're looking at the first 0.5. Well, if we look at the 0.5 here, that's this area here from 0 to 0.5. This is a zero line, a flat line, okay, which indicates a velocity of 0, and therefore the sprinter is not moving. They've got a 0 velocity, they can't be moving. Stationary would also be a correct answer here. We're then asked to calculate the maximum acceleration of the sprinter. Well, when is the sprinter accelerating? That's when their speed is changing, okay? And the only time during that period is really the period from 0.5 to 4.5 seconds. This says 4.5, not 45 seconds there. Okay, how do we do that? Well, we calculate acceleration as v minus u over t, essentially the gradient of that line. If you notice here, we've got a top of 8, take away 0, and we've got a time frame of 4.5 to 0.5. Okay, that's important that we make that that little recognition there, because some students do forget to take away the 0.5 there, and if you don't, then you'll get the wrong answer here. Well, in other words, that's 8 divided by 4, and that's 2 meters per second squared. Now, you could choose, to be honest, any number along this line. I've chosen the extremes because I find them easy. However, you could choose this point here, for example. Okay, you could choose this point here. It really doesn't matter as long as you read the values correctly. That's going to be fine. Okay, it's only a 1-mark question. All right, this acceleration is caused by a resultant force of 160 newtons. Calculate the mass. Well, F equals ma. Okay, and therefore we've got 160 divided by 2 equal to 80 kilograms. And again, this is one of those ones where you could think, well, is this a reasonable number? Well, it's a sprinter. Okay, may have a slightly larger mass than the ordinary person due to that extra muscle that they might have, maybe a particular stature. So 80 kilograms is reasonable. If you're getting 800 kilograms here, then that is far too big for the mass of a person. And I don't think I need to really go into too much detail on that one. Again, another point here is that the acceleration you are given, all right, it's just a case of using the value here. Now, let's imagine you just got a bit stressed out and you couldn't do question B. You can still do question C, okay? You can jump over B and go straight to C because we know the acceleration, we know it's 2 meters per second squared, and we know that our force is 160. So we can just go straight into it, okay? No need to worry there. It's not the case that if you don't do B, you can't do C. All right. We're then asked to think about the forces acting on the sprinter at various points during the race. And we're wanting to think about the horizontal forces acting at 5 seconds after the race started. So I'm just going to come back up to our graph. Think about 5 seconds. 5 seconds is here. We notice here that we've got a period of constant velocity. Okay, we are at a constant velocity there. Okay, well, what we want to think of is a diagram which shows me constant velocity. Now, a lot of students get confused at this stage because we know we're moving, and so they might think, for example, we're moving forward, therefore the force forward should be greater than the force backwards. You can see here I've scored this one out. Okay, why not? Well, actually, we do not need a forward force in order to move forward. Newton's first law tells me that as long as the forces are balanced on me, then I'm going to continue with my motion. Okay, so actually here, this is the right answer. Why? Well, at 5 seconds, the sprinter has a constant velocity. And in order for that to happen, the forces must be balanced. In other words, the forward force and the backward force must be equal to each other. And you can see that here, given those size and direction of those arrows. So don't be confused there. Just because we're moving forward doesn't mean that we have got, it doesn't mean we have an unbalanced force. Okay. This question, I think, is really a tricky one for people in terms of getting the marks, so let me just go through it. We're looking at the sprinter's skin, and it's coated in sweat, and we want to talk about the energy of the particles and how the sweat cools the skin. Well, first thing here is CIE looks for you to talk about evaporation. The sweat becomes evaporated from your body. Okay, I've seen answers which talk about osmosis, for example, which unfortunately is not quite correct here. The sweat molecules will gain energy and therefore leave the skin. Okay, that's our process of evaporation. We need an energy input in order for that to happen. That energy comes from you. And therefore, the particles in the skin lose energy and cool down. So really the idea that we need in our explanation is 1, a statement of evaporation, 2, a statement that our sweat molecules are somehow gaining energy. In this case, they're gaining energy because the skin particles are losing energy, and therefore they are cooling down. And that's how this process works. Okay, last one, and again, this is one that a lot of students like. Okay, so it's simply describing some differences. So you notice in these journeys, in these questions, we go through a bit of a journey. So maybe it's a nice, easy start, then a bit harder in the middle, and then right at the end, we get a nice question like this one. Okay, common answers here: bubbles in boiling, none in evaporation. In boiling, it's throughout the liquid, whereas in evaporation, it's only at the surface. And boiling occurs at the boiling point. Evaporation is at any temperature. I've concluded this part 3, so we can see another one. Okay, often they will tell you one difference and then ask you to state 2 more. So it's always good to have 3 up your sleeve. All right. But I also want to make sure that when you are writing this, you are talking about temperatures. Sometimes I notice students will write evaporation happens at any time. And whilst I understand what you are writing, I cannot guarantee you that CIE will give you the marks for that. So just be uber careful there. You will talk about temperatures as opposed to times here. Once more, take your time to look through these. Okay, this is generally a well done question, but one with some little tricky points, and then get ready to move on.